All right, everyone, thanks for joining us today. My name is Bassanio Peters. I'm the founder and CEO of Assist to Develop, the host of the Grinding Gears podcast, and I'm also the host of this new webinar series we're kicking off where we're trying to demystify innovation. And the first person I can think of to have a conversation about this was none other than Steve Rader. And Steve, do you want to give a quick introduction, introduce yourself, and then I'll talk about how we met, because it's actually a pretty funny story.
Yeah, absolutely. So my name is Steve Rader, and I am the program manager for the NASA Tournament Lab and NASA's Center of Excellence for Collaborative Innovation. And I'll talk more about that today, but I've been at NASA now for, I guess, about 32 years, and in this role for coming up almost 9 years. So yeah, lots of good stuff going on, and we'll have a good conversation today.
Yeah, and how I met Steve is actually kind of funny because we had an idea for this platform that we're creating with Assist to Develop that we created. And I was like, who are the big innovators out there? And I wanted to make sure to just really take a stab at testing the idea and see what we can learn from it. So I reached out to Steve. It was like November a couple years ago, a LinkedIn cold email. I think I sent it at like 2 a.m, which means it was like 4 a.m. Steve's time. And a couple of days later, got a response and we kind of kicked off a conversation. And again, the reason today that I wanted Steve to come and share a bit of his insight is I've seen this presentation that he's done before, and it's very insightful, not only for organizations and companies that are struggling to innovate. And I'll just drop a couple of statistics here. In 2019, $581 billion was spent on corporate innovation, but less than 6% of executives were quote unquote satisfied with innovation performance. And if you think about innovation, a lot of the times it does come down to talent. And 84% of executives, according to Deloitte, said that they struggle to find like top talent. So this is a big struggle, obviously, right now with COVID and everything going on. So open innovation and using challenges as a mechanism to not only discover ideas and talent is a way that kind of merges and brings that gap together. Steve has a presentation he's going to go through, and it's going to be very conversational here. And Steve, I'll kind of let you take it away from here.
Okay. Let's see. Hopefully you can see that now.
Yes, we can.
And let me move this right over here. Well, I'll just dive in. So we've been working open innovation at NASA for about 10 years now, and in what I've found is, as we're talking about this, that people really need to understand why open innovation, why do we even care? Why is this going on? Why do all these CEOs care about this? And so in our experience, what we started to realize is that there's something bigger going on. And this is telling people something they know, but they don't know. That the world has changed, and it is changing. But I think what a lot of people don't realize is it is so much bigger than they realize. And the rate of change is actually starting to break significantly things that have worked for the business world for over 100 years, right? And this is a big deal. So let me just walk you through a little bit of that. Over the last 50 years, in my lifetime, the world's population has doubled from 4 billion to almost 8 billion. And if you look at how countries have gotten more wealthy, and over that span of 50 years, they've built universities, and progress has been made. There are things like, over the past 20 years, there are 2.5 times more people coming through secondary education, to the point that now all of that's coming to fruition, and 90% of all scientists that have ever lived are alive today. Think about that.
Mm.
All of these faces you see right here, those are the faces that came up with electricity and physics and math and calculus. And now 9 times that many scientists are at work, given that those foundations and those technologies and those tools. And so we're seeing this huge spike, and you can see it there on the patents, that just a few years ago we were in the hundreds of thousands of patents per year. And by 2017, that had surpassed 3.5 million, to the point that it's kind of breaking the patent system. But you can look at the same stats for research funding and for number of PhDs, and on and on and on. And when you look at it, there's some things that jump out to you. One, this rate of change isn't just bringing us lots of technology, it is bringing more and more technology in this rate of change that is getting faster and faster. And part of that is driven by what I call these technology building blocks. And a lot of these are very low cost and very accessible. And a lot of you are a result of this, right? You've learned your CAD tools and modeling from tools that are very accessible, and the learning for that is very accessible. But that includes not just additive manufacturing CAD world, but blockchain and cheap sensors and automation and machine learning and open APIs. Even things like quantum computing now are accessible to everyone to go learn and go implement. You can literally get on open APIs for quantum computing. How crazy is that, right? And so you've got all of these people out there that have easy access to these technologies and tools and learning, and they're starting to combine these things and come up with new solutions. Think about even CRISPR, which is gene editing.
Right.
How crazy is that you can go buy a $200 kit to edit genes? That should just scare everyone. So all of this technology is accessible, but it's also something else. It is multi-domain. In other words, while some of these could very much be used in the automotive industry, it could also be used in medical industry, or in the aerospace industry, or in farming, or you name it. Most of these technologies are domain and industry agnostic, which means, go ahead.
No, sorry, I would just want to go back and add some color to this, because I think you're talking about it. We're going to get into this later in the presentation and in the conversation, but I just want to, come right out and speak on it. Like, this is an opportunity for a lot of individuals out there, because as Steve's alluding to, a lot of this information has never been as accessible as it is now. And, COVID has helped accelerate people's opportunities and basically chances to learn, because you're home, you have these opportunities to truly take advantage of basically what the future of work is going to be. So how can you get ahead? How can you start to take advantage of some of these opportunities that are sitting right in front of you to learn different, very dynamic, very interesting professions that you can then start working with top companies, top organizations? And again, we'll get into that in a minute, but I just want to, harp on that point, because this also opens up the door for more diverse individuals to get into the workforce via these mechanisms.
Yeah. And what you're getting at too is really interesting, that these skills that you learn now have such a bigger market, right? Additive manufacturing right now isn't just in, building plastic components, but now in aerospace, in building high-end metal, thrusters for spacecraft. And you can go in, there's home building now that is happening with 3D printing, and there is new garment industry coming up around 3D printing, and there is a whole area of food 3D printing that I've been fascinated with because it's just getting started. But I've been fascinated with this for years. And I went onto Amazon just to see if I could buy a food 3D printer, and there were 12. I
Oh,
could buy
wow.
12 different brands of food 3D printing. And just the way those are now being spread across industries is amazing. And you'll see that people are using machine learning with additive manufacturing or with blockchain or with automation. And all of these are being combined across different industries. And what's really happening, and when innovation, people talk about disruptive innovation, one of the things that's happening is that you can't possibly monitor everything that's going on. And so you might have John Deere over here working on a machine learning and automation solution that if you were to see a presentation on it, you would think, oh, well, that's great for them, but it couldn't help me over here in, say, medicine. But that's because they're using farming lingo and they're using a whole different set of problems. And you really have to have somebody who's special that can translate between those. But it turns out what's happening is technology are incubating and maturing in one industry, and then suddenly someone like connects the dots and pops over, and all of a sudden there's a mature technology that's competing with the existing, and industries are being disrupted. And I'll show some examples of that.
Sure.
So the situation we're in is that at no other time in the history of the world have we had so many amazing new technologies that are just growing and maturing and appearing out of nowhere and available. But the con, and it's a big con, is you can't find it. You actually, the skills needed to understand, how many of you understand quantum sensing? That's a new thing. Like, how would you even know if that could help you in your technology? How would you know that that's something you could leverage unless you learn about it? So it's not just that the technologies are behind IP firewalls and at startups and around the world and in government work, but also the skills necessary to even understand those technologies are hard to find. And those combinations make it really hard when you are trying to be competitive in an organization and produce the next cutting edge thing, and not let your competitor come out with something that's going to disrupt you. How do you do that? And a lot of people are still stuck in the mindset that they can just go to some trade shows, talk to some vendors, and Google, and they'll somehow know what the latest and greatest technologies and innovations that will help them will be. And that's simply not the case. So here's the problem for companies, is that this rate of change, this is my panic chart. It's meant to be like the tunnel is passing you by here. But companies are finding it hard to find the skills and expertise and hard to keep up with these tech advances. And thus, they're at high risk of being disrupted. And so that's why all these CEOs that Bassanio was talking about are kind of in a quandary. How do they get this innovation? What is innovation? They know it's coming because guess what? They see the stats. Some of our most successful companies, the one that made it onto the Fortune 500, over half of them have gone away. The average lifespan of companies over the last 100 years has shrunk from almost 100 years to down less than, I think it's actually down closer to 16, 17 now years. And that's a big deal. Like, if you think about it, it means that not everyone's surviving because they're being disrupted. Well, it turns out that at the same time that this rate of change problem is appearing, is that over the last, I'd say, 20 years, crowdsourcing has matured. And this idea of open innovation. So we say open innovation. Open simply means going outside of your organization, right? And innovation is, we know what that is, right? Trying to find that next big thing that's going to make a difference to our offerings, right? And it turns out that crowdsourcing ends up acting as this net, this like drag net across all these disciplines that can access the people that have the right skills and the right ideas and the right backgrounds and the right knowledge to connect the dots for existing technologies and start connecting dots about what's possible and start putting that innovation to work. And it turns out that within your company, you have this tiny little knothole to figure that out. But in open innovation, you end up being able to see and access things all across the world, just statistically, because a lot of these crowdsourcing platforms are literally tens of thousands, if not millions. And in fact, it's really remarkable how much they've caught on. In the disruption world, I just want to give you a real world example, because when we talk about this, it sounds a little abstract, but it is happening every day. So Subsea 7, their innovation manager, Gavin McClafferty, is a friend of mine, and he told me this story. He said, this is one of many stories, but he goes, we do pipeline bundle inspection. So we lower a piece of hardware down to off of a ship that we've taken out at $1 million a day, right? So not an inexpensive thing. They take this van-sized sensor that they lower down next to that pipeline bundle, and then they spend 2 weeks basically doing this pipeline inspection, right? And they went out to Nine Sigma and said, hey, let's see if we can use the crowd to find something that can do this better and faster. Within 2 weeks, they had discovered a technology that was already matured and in use in the mining industry, that was handheld and could do that same job, not in 2 weeks, but in 2 hours. So think about this. They just saved millions of dollars, right? Which is attractive in and of itself. But what the takeaway for them was, holy moly, if our competitor had found this technology before we did and locked it down, we would no longer be in the pipeline inspection business. That's what disruption looks like. Mature technologies popping over to another industry, and suddenly there's a 100x improvement that you can't compete with, right? So that's what these crowd platforms are actually providing, what I call low friction matching at scale, which you've seen on other crowd platforms, right? Uber is basically 5 million drivers who have cars that are being matched with people that need a ride, right? But that matching is very specific, right? It's very local. It's who's available right there, can get to you fastest, get to you at a low rate, and with high trust, I like to point out. I don't know if you remember when you first heard about Uber, but everyone I know, the first thought that they had was, there's no way in hell I'm getting into a stranger's car. That's crazy. And if you noticed, Uber built up that trust. So it's low friction. I punch a couple of buttons and suddenly I'm in a car, and then I leave the car and I don't worry about anything, right? I don't have to pay anybody, even though it's really happening. Same with Airbnb, right? I'd never go sleep in a stranger's house. Nope, that trust has been built. Now everyone uses that like it's nothing, right? This same thing is happening for all of these crowd platforms. But what you're matching on the innovation and open innovation world is you're matching the best solution for what's going to solve my problem, what's going to get me that 100x. And you're doing that in a way that the algorithm is actually something different than a software algorithm in a lot of cases. It's actually going to be a contest. So we work with a bunch of curated communities, right? And Assist to Develop is actually one of those communities. And for a lot of people, I have to explain what these communities are. You guys actually know, but it's a two-sided network, right? It's a website platform typically that has drawn in members from around the world that have a passion. So you guys, similar to GrabCAD, right? You have a passion for mechanical design, and you're learning from each other. You're connecting with other people that have that passion, and it's really about you and your development and opportunities, right? But there's another side, and that's customer facing. And the idea here is that these communities are able to find that win-win that helps the community develop and have opportunity and to make money, or to to learn or to connect with people, but also can deliver solutions for organizations. And it's really funny because in the early days, it became very apparent that these communities couldn't just take advantage of the users because the users were there voluntarily. So as soon as they had a really high detection rate of you're using me, and so they would just leave the platform and they wouldn't get any participation. And so now there's this kind of idea of win-win, and you're seeing that at Top Coder with 1.5 million software developers, HeroX with solving hard problems, and it's a really interesting way to mobilize people around passion. Because let's face it, people that have a passion and crowds that are diverse are always going to have better solutions than just a paid workforce that's kind of just kind of like feels like they have to show up. So I mentioned the matching algorithm that works for innovation, and in innovation that is challenges. Challenges turn out to be this matching algorithm that find you that high value, but you have to be careful because it's a very high signal to noise ratio problem, right? Because if you appeal to 100,000 members and they're all giving you ideas, you now got to filter 100,000 ideas. This is where the platforms are finding really interesting ways to develop a capability. So one is formulating a problem statement, very important step that a lot of people skimp on, and the ones that aren't successful, typically they haven't spent the time understanding the problem and formulating the statement. Designing the challenge. How many people should I award? How big should the award be? What are the awards? Is it monetary, or is it like an internship opportunity? Or is it reputation? Or is this an altruistic opportunity? Or is it simply a hard problem that we want to challenge the community to learn about? They execute the challenge. They know actually how to answer the phones and keep deadlines going and have the terms and conditions all fair. They solution filter, right? A lot of crowds are now looking at how can we use our crowd to help that signal to noise ratio. So they filter out and only find those submissions that meet all the requirements at a minimum, right? So they kind of get the trash submissions out that if somebody doesn't know what they're doing are in there. And then they help you pick the winners and get that right IP solution where it's either licensing or sometimes it's outright because there's no value in me keeping a certain solution because I can't do anything with it. And sometimes it's leaving the IP with the winners so that they can go make a startup. It just depends on what you're trying to do. So I want to give you just
add to that really quick. I just want to add some color because there's new models and stuff that are coming out as well, and we're actually working on something too where if you think about it, formulate the problem statement, design the challenge, execute the challenge. But what if an organization because let's be honest, like we're talking about open innovation here, but there's still a lot of companies that are apprehensive, just like people were apprehensive to use Uber, just like people were apprehensive to use Airbnb. Think about the cloud. People were, I'm not putting my photos on the cloud. I don't trust the cloud. So we're in that same stage and rate of change. So there's organizations right now that are like, this all sounds good, but I'm so concerned about IP and all these other things. Well, hey, test it. There's models now, and we're working on one where you can actually test it. Put out a challenge, but the sole purpose being, again, 84% of those executives are like, hey, talent is a big issue for us, and technical talent. Put out a challenge where it could potentially be a stock challenge or some sort of subset of problems. And then you get to actually test the model, test the platform, see how it works. And then you're not only going to get innovative ideas because you say, hey, it could be something vague, it could be something specific, it can be a stock challenge that you pay an organization to create and you're basically sponsoring it. And then what does that do? That gives the individuals an opportunity to, again, gain that reputation. If they do very well in the challenge, maybe they're awarded a job, an internship. It also, think about the skills and in the future of work. How do I build my portfolio? I spoke to a lot of different students at one of the SolidWorks World years ago, and they're like, every single job says you need 5 years experience to get this entry-level gig. Where am I supposed to get that? So these challenges can actually be a mechanism as well for you to develop those skills. And then again, go back to, hey, here's these learning paths, here's these opportunities. Doesn't have to just be CAD, it could be machine learning, it can be anything. Go through these learning paths And then to test that you've mastered these skills or at least have some grasp on it, participate in the challenge. And then that democratizes and levels the playing field. It doesn't matter who you are, where you come from. If you have the best idea to solve this problem and you can prove it, I don't care what your educational background is or where you're from. So that's where I feel like some of these newer models that are coming out too are going to give, again, better opportunities for organizations that are fearful, like, I don't really trust this, to test it. But then on top of that, give individuals the chance to participate.
Well, I think that's really great. And in fact, that experience thing that already trips over, right? You got to have this much experience. Challenges are a way to kind of bypass that and really show people, hey, it's not experience, it's capability. There's a great story about there's a data scientist that really, he wanted to get into the biosciences and use his machine learning experience there. And every time he applied for a job, they were like, you don't have enough biology background. You couldn't possibly help us with our problem because you don't understand the domain. And he got on a challenge platform and he ended up solving this really hard data science problem or biology problem using data science. And he won this challenge and really didn't even expect to. He just kind of submitted something and was like, well, I would take this approach. He ended up winning that and advancing biology itself in the process. And of course, then he was being hired by all these biology tech firms, right? Because now he showed what he could do, but there's this preconception for people of, well, I have to have this and I have to have this. And a lot of times those things end up not being true, right? And you can do a lot more stuff. Great point there. I want to talk a little bit about this idea of problem formulation. I have this little example I give all the time. There was a company that went to an incentive that brought this problem. They said, look, we need to remove grease from our potato chips, right? Everybody loves non-greasy potato chips. And the process they used would break a lot. They would actually mechanically vibrate the chips as they came out of the vat of oil, and it would break a lot of the chips. And we as humans only like the really big, full chips, right? That's important to us. The interesting thing about this is most food production engineers are mechanical engineers, right? I'm a mechanical engineer. A lot of you guys probably are. And vibration is one of the things that we are the world's experts on, right? And so this is a vibration mechanical solution that I would say is not a new problem, right? This is probably something that has been around for 50 years, right? And this solution is kind of the best they could do. Well, the first thing an incentive did was they actually changed this from how do you remove grease from potato chips to how do you remove a viscous fluid from a delicate wafer? Okay, same problem, just stated differently. And I talk about how important that is. Well, think about this. This did two things. One, it removed the fact that this was a potato chip company. And for competitive reasons, they didn't want their competitors to know that they were trying to come up with a better solution. So it kind of masked that, right? But more importantly, this broadened it from food production engineers and food scientists. Now, if you were in biology or in physics, you could read this and go, oh, let me think about that. Whereas before you would have read it, how do I get grease off potato chips? You'd be like, I don't know anything about potatoes. I don't know anything about, like, but this isn't that problem. This is a physics problem, right? And it turns out that the solution to this problem that won was to actually acoustically vibrate the air around the chip at this resonant frequency of the oil, so the oil flies off the chip but doesn't damage the chip. Brilliant, right? Yeah. But think about that for a second. This is a vibration solution. This is the very kind of solution that set of experts were the world, like, that's what they were trained in, but they remained blind to this solution. They just couldn't see it. And that's what we tell people is open innovation cuts across these blind spots and actually can bring innovation in an area. And you know who did actually submit this? It was a violinist. Who is also a vibration specialist, had seen the rosin fly for bow, understood kind of the concept, and submitted it, right? So you can't overestimate or underestimate the power of the crowd. And we see this over and over. I like to use this one because this kickstarted a program at GE that ended up saving them $6 billion. Okay. This was a challenge that General Electric, that Diane Finkhausen ran on General Electric's, or on GrabCAD about probably 6-7 years ago. And they basically said, look, we have this engine bracket that sits on our engines that we want to redesign for 3D printing. We have these new metal 3D printers that are coming, and we want to see what we can do here. And we don't really have expertise in-house on how to redesign for 3D printing. As you guys know, 3D printed design is a very kind of peculiar piece of design work. So this was it didn't work in flight, right? This was a lifting bracket, so it wasn't going to be super critical. And they ran this. Then they basically got 600 entries. I think it was for a $10,000 prize, and they paid initially the first 10 they paid like $1,000 each, with the big prize being 10,000. 9 of the 10 of their finalists actually passed their stress. They printed them out and they passed their stress testing. The winning design was 83% lighter than their traditional design. Now think about that. In aerospace, a 2% savings in mass is a big win. 83% was incredible. So what they did is they ended up doing this whole series of internal challenges where they got their people to start thinking of how could the jet engine be redesigned. And you're going to see in the future, GE's going to start having fully 3D printed jet engines. And if you know anything about those blades, they're all micro machined channels that flow air through them. There's all sorts of really expensive machining that's going to be replaced by 3D printing. And it is going to cut the cost of aircraft engines dramatically. It's going to save a ton of money.
And
all of that started with
point. You made a point. I gotta.
Yeah.
Internal challenges. Like if you think about how many of these big organizations have so many different divisions that don't communicate and talk to each other, like that in itself. Like when you think about what are my opportunities, what are different things that we can do to help kickstart this? Like we're not ready. Again, we're not ready for open yet. I'm an advocate for open. You're an advocate for open. We've given so many examples of why. But if you're not ready, just if you're the CEO, think about how many people within your organization that are in different divisions can solve a problem you potentially have. And just, I'll throw that out there too, because again, I know people were apprehensive to use like everything we talked about, but this is the chance.
We ran a challenge for a urine monitoring. It was basically to measure urine volume in microgravity, right? So fluids in microgravity, really hard to measure anything. And this guy was about to go do a whole SBIR, like phase 2, 3, like 3 to 5 years, $1.5 million. And he ran an internal challenge at NASA and said, look, I'm trying to solve this urine measurement problem. And it turned out, I'm not kidding, a lab 300 yards away from his building that worked in a whole different area had a working prototype for a different purpose that he ended up being able to find through an internal challenge. Saved him all of that discovery time, $1.5 million of development, 3 to 5 years of development saved by a 4-week challenge internally. So internal challenge is a great way to kind of tap into that. So again, we're the NASA Tournament Lab. That's our public brand. We work across the whole federal government and of course across NASA, helping projects to learn about how to use these tools and how to tap into this power of the crowd. We do this kind of roadshow for them so that we teach them about how this works. But, you guys are the crowd we're talking about. So it's really kind of fun to be talking to you guys about this. We actually have contracts in place that hook us up with about 40 different crowds that represent 120 million people worldwide. And in fact, we're providing the entire federal government with access to these different crowds depending on what they're trying to do. And I'll just give you some examples of what some of the challenges we've run. This Exploring Hell challenge we just did I don't know if you know this, but when you're trying to work on the surface of Venus, it is super hot and high pressure. And I think the longest anything's survived is less than an hour working on the surface. And we're trying to get stuff that goes over months. We ran a challenge on Hero X, ended up with something like 14 different really interesting designs. One of them actually went out and built a working prototype where they actually put it out there and actually learn how they could actually do this by building something, right? So there's some really amazing work that people get done as part of these challenges. This Honey, I Shrunk the Payload challenge is a whole new way of NASA going out to the scientific community, or really anyone. That's the thing. It actually opens it up to anyone. And this one was to create new payloads the size of a bar of soap that they can put on micro rovers for the moon, right? And they're actually building, like, these contests are set up not just to find them, identify them, but then to take those people and give them funding so they can actually compete on the next level and build the actual flight units that will have opportunities to go and run on the surface of the moon. So you can see we ended up with something like 14 different prizes awarded here. Those are now in a phase 2, and we're maturing those to go fly. I actually ran this was my first GrabCAD challenge I ran, and it was to actually redesign the hand clamp or the handrail clamp that they use on space stations. They make this little clamp with a little cedar rail that then they can mount a laptop or some camera or whatever on the space station handrails. And we ran this really as a trial on GrabCAD with a $2,000 set of prizes. We ended up with almost 500 submissions, and you can see they were many and varied. And it was really a eye opener of what talent is out there, and the fact that in mechanical design we think of it as just this step in the engineering process, but what we realized is the creativity in the approaches is very varied. And it's very possible that you can get some really innovative designs and approaches that could save you mass, could save you assembly time. We did one of these later that was to do a mounting system for a payload in the ISS racks, in the space station racks. Right. And it wasn't that just it had to be light. It had to be something that the crew could actually easily deploy with just like one hand. And like it had all these requirements about how small it had to compact to, how many steps. And we ended up with some really amazing kind of deployable solutions that just kind of unfolded and attached with the fewest number of steps. And again, you don't get that with just one or two engineers that are working a process. With this kind of thing where you're opening up at very discrete points in the design process, gets you that openness. And if you're mechanical engineering and hearing this right now, you should be processing it this way. I can use open innovation challenges to actually get a better starting point for my innovation. So imagine this: somebody hires you to go build something and get a design together. Why don't you go run a couple $100 challenge and get 5 or 6 designs in from other people on aspects of your design? Then you pick from those and then vamp on that design to get you a better design. Think about the power of creativity of the crowd. And that couple $100 actually is a chance for other people to try out stuff, to show you their stuff, to get connected with you. You create a network of people you now know that as you get new jobs, you can, hey, I've got some extra work, I can't do it all. You get them involved. And you create this ecosystem within the open innovation community. So there's a huge opportunity for designers.
Think about it in terms of, again, some of these students that are just looking for the opportunity, because I can't tell you how many times I've talked to students and even engineering managers that give me this advice. They tell, oh, summer, you're home from engineering school in the summer, and they're like, oh, or growing up as a kid, just take everything apart, take stuff apart at your house and figure out how it works. Challenges are real world challenges and mechanisms that you can actually decide like, all right, these are the ones that I want to participate in. You know, obviously working with ones with you guys at NASA, that's great brand recognition, excuse me, for your portfolio, for your resume, et cetera. But it's also good practice. So you can go and participate in a bunch of these different challenges, show this is what I'm capable of. So not only mechanical engineers that are wanting to use this as a way to expedite and streamline their process of coming to the design, because like you said, there's millions of different people out there that'll give you different approaches to solve the same problem. And I think that's the benefit of
it. And think about it this way, those people that are asking for 5 or 10 years of experience, if you were to sit down with them and say, I don't have that experience, but here's a portfolio, and you participated in 25 challenges, even if you didn't win any or all of them, the fact that you've got 25 designs that they could look at and go, holy moly, this person, they've done some stuff, right? Because at a company, guess what? You might only do one design a year. Like, their processes are really slow. So when someone's looking for 5 years of design experience, you could potentially have that in a fraction of the time through these challenges. There's just a real learning opportunity. These are
tie the mentors too, because we have mentors that help judge these challenges, because then you're getting real world. Think about the senior experts that are retiring, taking their tribal knowledge with them, the skills gap in engineering and manufacturing. Now you have an opportunity to have some of these senior experts mentor these challenges, mentor these students, mentor any of these people that want to participate, say, hey, great job on this challenge, but here's some areas in which you can improve. And that's how communities grow and get smarter and stronger, and you get better results from these organizations. Absolutely.
Let me just tell you something about this algo challenge here, this lightweight lunar gantry that had to be inflatable. One of the winners of that was Lauren Fell. And Lauren Fell in 2015 was a psychologist, 20-something-year-old new graduate doing psychology, using user interface stuff. She won a challenge that was doing a storyboard for an RFID video, right? A video about this 3-minute video. She did a little storyboard. She got hooked when she won. But she only won like $1,500. It wasn't a huge challenge, but she went on to basically start competing in CAD challenges. But she initially submitted things in PowerPoint, like she was literally doing mechanical designs in PowerPoint. But the next challenge, she had learned CAD and was submitting CAD designs. And the challenge after that, she was submitting pictures of 3D printed parts, because she had gone out and bought a 3D printer. She had taught herself CAD, taught herself 3D printing, and then started learning about robotics and getting Arduino boards and starting learning how to do those. And so her submission for this actually was a working prototype with robotics components. Turns out now she's working on a PhD in quantum physics. I'm just saying there is learning to be had through these processes. The other thing I'll say is the AstroBee Robotic Arm Challenge series, we had 20, maybe it was 17 challenges, 23 challenges, something like that. Around 20 challenges we ran, some for component pieces, but this was for a tiny little arm that was on our AstroBee free-floating robot that we have on the space station, to kind of reach out and grab hold of the arm rail or pick stuff up, right? This tiny little robot arm had all these specs, and we put it out there in different architecture pieces. And we were really trying to study the way people put architectures together. But at the end of that, we took all of the submissions and the winners of that and reassembled them into kind of 9 reference designs. And when we measured the performance of those, the mass, how well they performed, all the kinds of things that we were trying to optimize for, 8 of the 9 composite designs outperformed what we actually fly in space. The crowd has some amazing talent. And one of the things that study showed was that it wasn't just roboticists. It was actually people who had some robotics background, but actually worked in a different area that were giving these really innovative designs. Okay. Just so you see, this is actually a little outdated chart. We're actually up to 600 projects now. And we've done not just, I think the ones we did with you were conceptual design, but as you can see, you can do all sorts of different work with the crowd. And we've done a lot with software and data science, but a lot with engineering models. And now we're doing whole things where we start with a concept and then move to a preliminary design and then go to prototyping and then do something to flight. And it's this entire contest-based kind of maturation. And it turns out it's saving the government. We're up to about $50 million in savings that we're saving the government.
Yeah, and I just want to talk briefly about the project we did. So we ran a systems engineering SysML challenge with you guys, and it was a pilot. We were testing out our platform. We had just launched it. It was a couple of years ago. And I know for us, it was like a 90% time and cost savings improvement on that challenge based on the data that you guys published. And we have a case study that I'll put a link in the show notes. You can go ahead and download. I'm not going to spend a ton of time on it. But what was interesting to me is everything you talked about. That's what kind of was my aha moment in this process, because there was submissions from all around the world. We had a university team in Madrid that participated. One of the winners was a consultant based out of France and a student from MIT. But then, you know, I know many people from the department that ran the challenge for you guys, you know, we're kind of thrilled because it was systems engineering. It's a very, and that's not even our background and our skill set. We're mechanical. You threw me a lob, so this is your opportunity, kind of take it or leave it. And I was like, oh, I don't know, Steve, but we're going to do our best. And it was just, I got to witness the power of the crowd firsthand in that challenge. And we've kind of doubled down and iterated and, you know, changed our platform a lot more since then. So obviously we do ideas, conceptual systems, engineering, like we're doing all of those things and looking to expand in the coming years. But that to me was kind of the big eye opener for me. And that's why we're listed on here, is because we did that conceptual challenge, but there's so much opportunity out there. And for us, we're really trying to focus on making sure that that opportunity is captured.
I'll say this too, because we're talking to the crowd, which I love that this is a conversation with the crowd. Don't be afraid to try something. Challenges provide you one of the few places in the universe of a no consequence failure. 100%. You can try something, and in worst case, you tried something out and learned, right? That's the worst case. The best case is you win. On our data science algorithms, we ran a challenge for the Homeland Security folks on the millimeter wave scanning. And it was to come up with an algorithm that could find weapons on people using that millimeter wave scanner. One of the winners of $100,000, it was like a 5th place winner. They had big prize money.
Yeah.
He was a freshman at Berkeley who started the challenge because he wanted to learn how to do machine learning. Okay? Didn't even know how to do it. Used the challenge to learn it, got to the part of the challenge that said, oh, you now have your algorithm. Now you need to train it. You need to give as much data as you can. And DHS had only provided, you know, like 5,000 like images, 3D images of people going through this thing. And he happened to already be a gamer developer. So he knew what Blender was, which is this kind of free tool for creating those very realistic looking people in video games, right? So he just wrote some scripts. And he was able to generate lifelike images that DHS had spent tens of thousands of dollars collecting with live people. He was able to create similar kinds of permutations all over the map in minutes, probably. And he was able to train his model better than anyone else, even though he had just learned how to do machine learning. And, you know, $100,000. So there's that.
It's not bad.
Not bad, right? And they offered him a job on the spot in the interview, and he turned him down because he's like, no, I'm still learning. Yeah. So anyway, speaking of, one of the things we noticed when we started working with crowds is that there's something else going on, that it wasn't just this kind of pink set of crowdsourcing communities that were running challenges, but there were these blue and yellow platforms that were gathering people around freelance and gig economy work, and that some were doing both. You know, Top Coder has freelancers and challenges. Freelancer is mostly gig work, but then they ran a few challenges too, and we started playing with those, and we realized, wait, something's going on here. This stuff didn't exist before, and it turns out that this is a big shift in the workforce. And you've probably heard a lot of this stuff going on in the news now, but these new platforms are taking this idea of low friction matching at scale and not just doing it with innovation, but doing it with labor. And so companies like Top Talent, Freelancer, and Upwork, and Maven, and BTG, and Kelly are all using smart algorithms to find freelancers that have the experience needed to go do a task, and they're matching people really quickly for firms. And this is, something I know you guys are playing with too, right?
Yep.
What we found is there's a study by Edelman Intelligence that showed that in 2017 they studied it, and they found that the number of people moving to the workforce out of full-time jobs and into the freelance was 3 times the rate of the regular workforce. And in fact, by 2019, the average for organizations was 40% non-full-time employee, which is roughly double what it was 7 years ago, right? And that was in 2019. It's actually increased since that. The trend back in 2017 was that by 2027, there would be more freelancers in the economy than full-time workers. That's a huge shift. Even if you're not a company using all those freelancers, guess what that means? Fewer people are going to come work for you. Guess what's happening right now? Nobody can hire. It's happened already because COVID just sped this up. Yeah. And so people are realizing, wait, I can actually work independently on one of these platforms. The platform brings me work from around the world. It's not one industry, so that industry can't necessarily go belly up and lay me off. So I have a more steady stream. And it gives me as a freelancer the opportunity to upskill, because guess what? There's a World Economic Forum study that came out about a year ago that said, look, COVID sped everything up. And this idea of automation taking people's jobs, that is real. In fact, there are 85 million jobs going away by 2025. Yeah. But there's also 97 million new jobs coming. The problem is the people who are losing those jobs don't have the skills necessary for those other jobs. It's kind of like there's a pyramid, right? It's what we're used to, like a few high-skilled jobs and lots of low-skilled jobs. And automation is eating those jobs at the bottom, and AI and machine learning, digital transformation are expanding the demand for those high-end jobs. But guess what? That leaves a lot of people out of work at the bottom, and a lot of people who aren't available for those jobs at the top because we're not upskilling fast enough. And that's really what this comes down to, is this lifelong learning paradigm that these platforms are now actually showing that they can facilitate faster lifelong learning. And full-time employees, they're not given any time. The average budget for companies is $1,000 per employee per year. And that's mostly compliance training. It's not upskilling. And so people are moving into the freelance workforce, not just to go make money, but because they realize the value of learning. I talked to this one freelancer at Top Coder who was one of the top folks on their freelance site. And I said, hey, how much time do you spend learning new software, learning new techniques, new technology? He goes, 60% of my time. I said, what? How do you make any money? He goes, oh no, in that 40% of time that I work, I make 5 times what anyone else in Greece makes. 5 times. And it's because he's learning the in-demand skills. And those in-demand skills pay more. Yeah. Right? And so this new kind of freelance world where people have more agency and they pick what they want to do, people are learning how to do that learning to fill those gaps at the top, because that's what's paying, right? And if we can find a way to pull more people from that lower end of learning up through that, we really have a chance against the automation problem. Because guess what? That same World Economic Forum report showed that 50% of employees will have to be reskilled by 2025. Yeah. The next 3 years, right? We're almost to 2022. And that of that, 40% of their skills have to change. And they looked at the training needed to upskill them. And it's not that $1,000 per employee per year. It's literally months of training that is needed. That's tens of thousands of dollars per employee worth of training. No company is set for that. So companies are really in a problem state right now because they can't upskill their folks. They're so used to the recruit and retain model that they don't know what to do. They're trying to hire their way out of this, but who are they laying off? They still need those people. So the complexity of technology, the folks they need, it doesn't match up. And so there's a real problem here. And so both open innovation and talent tend to be the thing. So what I tell people is like, look, this might get off the stage chart. Open is the future. you we, with the complexity of the world, you can't possibly own all the skills you need and get all the innovation you need within your organization. You have to use open. And innovation, you used to be able to do that every 10 years, innovate on something, produce that for 10 years, and then you could come up with something. We haven't been in that world for 20 years. Now, if you're not innovating as an organization, and honestly, as an individual, you're probably not going to be relevant for much longer. So learn how to innovate. Go learn about Scamper and go learn about Six Hats and Tina Seelig at Stanford. Learn about how to innovate as an individual and then participate in this stuff as a way to upskill and learn, because more and more these platforms are going to be the go-to for organizations, because that's where the labor is going to be. That's where the smarts are going to be. That's where innovation is going to happen. And doing that all in-house is going to just become increasingly irrelevant. So this whole, whoever doesn't figure this out is going to be left behind, that's actually already been happening. So with that, we can chat more and just,
if you're one of those people that are fearful of, hey, the rapid scale of change because of COVID could cause me to potentially lose my livelihood and job, find those opportunities for you to learn and then apply those skills and challenges. And as Steve said, test it. What's the worst that can happen? Win $100,000 like the UC Berkeley kid? Like this is a great time that kind of levels the playing field a bit. And that to me is what is so exciting about this.
Oh, absolutely. In fact, we talk about this as the democratization of work, right? And we call it the passion economy, because people are kind of freed from, people I know that are passionate about what they do will go work for a company and they find the Dilbert cartoon there, right? Where they only get to do their passion this tiny bit of time, and even then it gets stripped away from them in this kind of unceremonious way because of the way companies work. And I just like, it's fascinating to watch people live into their passion and doing that. Right. And we call it the passion economy, because people are kind of freed from, people I know that are passionate about what they do will go work for a company and they find the Dilbert cartoon there, right? Where they only get to do their passion this tiny bit of time, and even then it gets stripped away from them in this kind of unceremonious way because of the way companies work. And I just like, it's fascinating to watch people live into their passion and doing that. There are so many opportunities for folks to learn and to exhibit that. There's a great book, if you haven't checked it out, called Cognitive Surplus by Clay Shirky. And he really talks about, look, we now live in a world where people have, 4 or 5 hours at night where they're binge watching or, doing, you have more capacity and time to go participate in. And he says that's really what's happening. If you look at the world's largest repository of information, Wikipedia, that was built just by people's extra cycles. Like, that's not paid anybody. And yet it totally upset the entire encyclopedia market that used to be ruled by just a few players and took decades to produce a whole new set, right? And now it's this up-to-date very interactive platform. So the fact that we are in this state of rapid change and adaptation is just amazing, and it's fun to watch people as they embrace the learning and embrace the passion. So
Yeah.
great stuff.
And I guess I'll close with this. Like, my whole thing starting this company years ago was, the democratization of innovation, and it's really helping anyone, anywhere create anything. And then you think about Web 3.0, everybody's talking about that, blockchains like Ethereum and these other tools that are accessible and available. Who's to say that someone in a third world country can't raise their hand and say, hey, we have this problem here. Is there anybody with this domain expertise? And this happens on a platform to solve it. And people can come together to solve problems. We don't have to wait for the bureaucratic processes and all these things. It can be a group of people that come together and solve the problem. Because if you think about it, the person in that third world country is on the ground. They understand those problems better than myself or someone else. So they can say, here's what we have, these issues, and then boom, you have a group, a crowd of people that come together to solve this problem. And then you have these platforms that, again, in the future of the internet, technology, we're going to see some rapid transformation and change in the next, I would say, 3.5 years. It's going to accelerate because of COVID. And I just want everybody to have the opportunity to take advantage. So Steve, thank you. This was so insightful, not only for organizations, but you and I both get excited talking to the crowd, because we're like, there's this big opportunity in front of you. Take advantage. Yeah. So your energy always comes through. I appreciate your time. Where can people find you if they want to reach out?
I'm on LinkedIn. Just, find me, Steve Rader. Usually you put in NASA, you'll find me. But I'm on Twitter, Steve Rader. NASA Solve is our kind of organizational Twitter. Oh, perfect. Watch that at NASA Solve. So yeah, lots of great ways to connect, and looking forward to connecting with everyone.
Steve, thank you again for this. Have a great rest of the day, rest of the afternoon, and we'll catch up soon.
Thanks for signing.
Thanks.